Hi guys, so now we will have a new subtopic. We have done our part A, we have done our chapter 5 part B, and now we will move on to the last subtopic in chapter 5, chapter 5 part C. Let's recall back. Chapter 5 part A is all about confidence interval. You want to estimate population based on sample. So chapter 5 part B is all about hypothesis testing. You want to test your hypothesis. You want to test your parameter using the measure from statistic. So for now, you will have chapter 5 part C. Statistical analysis for means also, but we will cover more than two population mean. Okay, let's look at what we have in the content. 5.4 Statistical analysis for 3 or more population mean. Now the case is you have mu1, mu2, mu3 and so on. So because you have more than two population mean, you cannot longer using hypothesis testing traditional. You have to use what we call it as ANOVA. So we'll cater on in this subtopic. So 5.5 statistical analysis for means using Excel. So we will conduct statistical analysis using Excel. Next, 5.4 statistical analysis for 3 or more population means. So before that, let's recall a little bit. If you have mu1 and mu2, you want to see is there any difference between these two mu. You can use hypothesis testing, H null. So you have to test H null mu1 equals to mu2 and H1 mu1 not equals to mu2. So how about you have more than 3 population mean? Mu1 equals to mu2 equals to mu3 equals to mu4. You cannot longer use this traditional hypothesis. You will use what we call it as ANOVA. So the ANOVA we will cater in this subtopic. Right. Introduction. Definition. What is ANOVA? ANOVA is a short form of analysis of variance. We call it as ANOVA. So here you will have ANOVA. ANOVA is the short form of analysis of variance. Okay, what is ANOVA? ANOVA is a statistical technique used for testing the equality of more than two mean. We want to test the equality more than two population mean. For example, you have mu1, mu2, mu3. You want to know, is it these 3 mu equal or not? So we can use ANOVA. There are two types of ANOVA. The first one is one-way ANOVA. In one-way ANOVA, it's involve one factor and do not involve interaction. So in two-way ANOVA, we talk about two-way, you will have two factors and it's involve interaction effect between the two factors. So we'll look at one by one way ANOVA and two-way ANOVA. Okay, this is the assumptions of ANOVA. So the ANOVA said that the population being studied are normally distributed. So it is normal distribution. The samples are independent and the population have equal standard deviation and variance. So these are the assumptions of ANOVA. So in ANOVA, there are two methods. First, we call it as the conventional method, where we use the 5 steps of hypothesis testing procedure. Okay, step number 1, your H null and H1. Step number 2 is the test statistic, and the test statistic used in ANOVA is F test. Step number 3, we will determine the critical value. So you will have this one. And step number 4, we make decision by comparing F test and F critical value. If F test is greater than F critical value, you have to reject H null. And step number 5, draw your conclusion. So next, we also have another method. We call it as the p-value method. So the p-value method here, p-value we will using Excel, Microsoft Office Excel. If in conventional method you have 5 steps, in p-value method you have 4 steps only, simple. So step number 1, also your H null and H1. Step number 2 is no longer test statistics. Step number 2, we have to get the p-value based on the Excel output. So we will show you how to use the Excel to get the p-value. And then step number 3, same, make a decision. But here the decision is different. We will reject H null if p-value less than or equals to alpha. So you have to remember this one. If p-value equals or less than alpha, reject H null. Okay, and lastly, draw your conclusion. Okay, look at one by one. 5.4.1, one-way ANOVA. Okay, these are the model for one-way ANOVA. You will have here, this is the model. Alright, in one-way ANOVA, before we go for the hypothesis, step number 1, you have to know in one-way ANOVA, okay, there are a few things that you need to know. First, in one-way ANOVA, it's involved one factor. Means that you have one independent variable. Okay, so you will have one independent variable, and the independent variable will determine your treatment. So don't worry, we'll look at later on what is independent variable and what is treatment. So step number 1 in ANOVA is hypothesis. So as we know, we must have H null and H1. So what we want to test actually, we want to test this similarity between more than 2 population mean. So the null hypothesis, H null is mu1 equals to mu2 equals to dot equals to mu k. K here is referred to your how many treatment you have. Okay, so we look at later on what is treatment, or you can write down all population means are equal. Okay, if our H null is similar, how about H1? Alternative hypothesis, H1 mu I is not equals to mu j for at least 1. So maksudnya salah satu population mean itu tak sama. Okay, sama ada mu1 tak sama dengan mu2, ataupun mu2 tak sama dengan mu3, ataupun mu1 tak sama dengan mu3. Tak semuanya tak sama. Salah satu ada yang tak sama. If you don't want to write down like this, you can write down in words. At least salah satu population mean is different. At least one population mean is different. So you can choose. You want to write down your hypothesis like this, or you want to write down like this, also can. You want to write down like this, or you want to write down like this, is also acceptable. So your H null and H1 is not changed. This will be your H null and H1 in ANOVA. But how many mu you want? Let's say you have 3 treatment, k equals to 3. You will have H null mu1 equals to mu2 equals to mu3, and H1 mu I not equals to mu j for at least 1 I not equals to j. So like that, it depends on the treatment. treatment depends on the independent variable. Right. Okay, step number 2. Step 2, you want to determine the F-test. You want to determine the test statistic, the F-test. Lastly, we want to calculate this F-test. In order for you to get this F-test, you need to create the ANOVA table. So the ANOVA table will look like this. You will have source of variation, sum of square, degree of freedom, and mean square for the column. For the row, you have the treatment, K. You have the error, E. And you have the total, T. So now, our aim is, we want to get this F-test value. In order for you to get this F-test value, you have to go through all this procedure. First, you need to have your SSTR and SST, sum square treatment and sum square total. So don't worry, SSTR and SST will be given. But what you need to do is, you have to find what is sum square of error. Sum square of error is equals to sum square of total minus sum square of treatment. So this value minus this value, you will get the SSE. Okay, next, degree of freedom. This is the formula for degree of freedom. K minus 1. K is your treatment. N minus K. N is your total data. N is your total data. Okay, so now mean square. How to calculate mean square treatment? Mean square treatment is equals to this value SSTR divided by this value K minus 1. For MSE, SSE divided by N minus K. So this value SSE divided by N minus K. You will get the MSE. So now our aim is here. We want to find F-test. So what is the F-test formula? F-test is this value MSTR divided by this value MSE. You will get the F-test. So our aim, we want to find this F-test. So this general form, we call it as ANOVA table. So you need to construct your ANOVA table. You have to remember the flow. You have to remember the formula. Okay, let's look at the example. So we will show you how to answer example 5.c about one-way ANOVA. So be ready for the pen and a piece of paper.